In this question, what you need to do, there is one mole of an ideal gas passes through a process where pressure and volume obey the relation. Calculate the change in the temperature of the gas if the volume changes from V naught to V naught. P naught and V naught are constant. Okay, so you can apply the formula PV is equal to RT from a DT is equal to PdV by R. So if this is P naught, dV integration become V minus 1 by 2 V naught square. V to the power minus 2 dV become V to the power minus 1 by minus 1. So minus 1 by V. Now we need to put the limit. So initially that is P naught 2 V naught minus V naught in place of V. So it becomes only V naught minus V naught square by 2. Now the solution becomes this plus and minus become minus. So minus V naught square by 2 into 1 by 2 V naught minus. So this become 5 by 4 P naught V naught. There was one R, so 5 by 4 P naught V naught by R will be a solution. Here you need to do integration because the pressure and volume is continuously changing. Because pressure is a function of volume, pressure is not constant throughout. If pressure would have been constant throughout, then you may just apply T is equal to PV by R. But as the pressure is continuously changing as a function of volume, so that's why you need to make an integration. In the given question, this is a good one. Two thermodynamic processes are shown in the figure. The molar heat capacity for the process A and B are Ca and Cv. This is given as this slope is this angle is given as tan inverse gamma. So if you find out the slope, it will become tan of tan inverse gamma. Angle given is tan inverse gamma. If you find out the slope, it becomes tan of tan inverse gamma. So this one slope is gamma, and this one slope would be tan 45 degree, that is 1. So this is for A and this is for B. The molar heat capacity at constant pressure and constant volume are given as Cp and Cv. You need to choose the correct statement. C of any substance equal to Cv plus R by 1 minus X. So in the first process, in process A, as it is given, log P equal to gamma log V. So you may write P is equal to, you may write it as log 1 because log 1 is 0. So log P minus gamma log V, or log of V to the power gamma equal to log 1. From here P by V to the power gamma, or PV to the power minus gamma equal to 1. So now PV to the power minus gamma is equal to constant. In the same way for B gamma equal to 1, so you may write PV to the power minus 1 is equal to 1 or some constant. Now you know C is equal to Cv plus R by 1 minus X. So for process A, C equal to Cv plus So in this question, CB by R by 1 minus gamma. So this was becoming 1 plus gamma. So CA, you may write this CA. CA is equal to R by CB is R by gamma minus 1 plus R by 1 minus gamma. This is CA. For CB is equal to CB plus R by 2. So as you can observe, none of the options are correct in this given one. None of the options are being correct. So you may write that CP is equal to CP plus R and CB is equal to CB plus R by 2. So CP is more than CB, which is more than CB. You can't conclude anything about CA because you don't know the gamma. So none of the options are correct, but in some book this is given as these two options, these two are correct in some of the book, but that will not be the answer. If the graph would have been log p by 1 by log v, then it might, you can get this one or the answer. But in the given scenario, none of the options will be correct. Now moving on to the next question. So next question is, initially a gas of diameter molecule is contained in a cylinder of volume V1 at a pressure P1 and temperature 250. So the volume, initially a gas of diatomic molecule is contained in a cylinder of volume V1 and pressure P1. The temperature is 250 Kelvin. Assuming that 25% of the molecule get dissociated, causing a change in the number of moles, the pressure of the resulting gas at temperature 2000 Kelvin when contained in a volume 2V1 is given by P2, the ratio of P2 by P1. So initially the diatomic molecule was at 250 Kelvin, volume V1, pressure P1. So number of moles is P1 V1 by R T1. So among the total number of moles, 25% of the molecule get dissociated. So as 25% is dissociated, so n by 4, 3n by 4. This 3n by 4 is diatomic, but this n by 4 dissociated into n by 4 plus n by 4 monoatomic. So in this question, n is equal to P1 V1 by RT1, and later on this become n by 4 2 monoatomic and 3 n by 4 diatomic. So initially n equal to P1 by RT1. Later on pressure becomes P2, volume becomes 2 V1, and this becomes 2000 Kelvin. That means 80. So now what to do? Now N1 plus N2. N1 is n by 4 and N2 is n by 4 into 2. So N1 is n by 2 and N2 is diatomic, which is 3n by 4. P1 is P2, V1 is V2, V2 means 2V1, R is R, and T1 is 80 plus P2 into 2V1 R into 80. If you solve these two, you will be getting P2 by P1 equal to 5. Now in the next question, you have given 1 mole of an ideal monoatomic gas. The maximum temperature attained by the gas along the path This is a PV graph given. So in this graph, if you draw some isotherm, this isotherm will shape like this. So the maximum temperature of the isotherm means whenever you go from this way, the temperature increases. So the maximum temperature that will be attained will be a tangent to this one, will be a tangent to BC. The maximum temperature that will attain will be a tangent to this BC graph, because if it intersects at 2 points, then there must be some another graph, another curve which will be just touching the touching this tangent. Okay. In this question, you can apply this one. First you find out the slope. The slope is from let's assume you take 2 points. This is the B point is 3p naught comma v naught, v naught comma 3p naught, and this point is 2v naught comma p naught. Now find out the slope. Then find out the equation. P minus 3p naught is equal to minus 2p naught by v naught into v minus v naught. Then from there just transfer p to t. Now do differentiation dt by dv, you will get value of v, and put this v over here, you will get the value of p, and now t is equal to pv by r. So just multiply these two, so you are getting. So this is a lengthy process. In the tangent method, what you can do, just extend this one, get these 2 points. So this point would be 0, 5 p naught, and this point would be, and in this one in v naught gap you are getting, in v naught to 2 v naught gap, that means in this v naught the pressure is dropped by 2 p naught. So in p naught this is 2 p naught. So if this is p naught, then by similarity this will be v naught by 2. So the coordinate will be 5 v naught by 2 comma 0. So just find out the coordinate, and their middle point should be the point of maximum temperature. So how to get the middle point? Just 0 plus 5 v naught by 2, that means this is 5 v naught by 4, and this is 5 v naught by 2. Just add up them, x1 plus x2 by 2 and y1 plus y2 by 2. This should be the middle point, because the tangent will be, because the isotherm will, this line will be the tangent to the isotherm. So this is your point, 5 v naught by 4, 5 v naught by 2, which we get by calculation. From there onwards you can find out the value of t. This point will be the middle point of these 2 points. The point this means the middle point of the intersects, not the middle point of BC. This point will be the middle point of the intercepts. For an ideal gas, the instantaneous change in pressure P with volume given as d by dv is equal to minus AP. P is equal to P naught and V is equal to 0. Maximum temperature of 1 mole of a gas can attain. So given as this is given, dp by dv equal to minus AP. The boundary condition is given as P is equal to P naught at 0. So let's integrate this one. You get ln P is equal to minus AV plus some constant. So just put the boundary condition. In place of V, just put 0. So ln P naught will be equal to C. Now rewrite the equation. Ln P equal to minus AV plus ln P naught. It becoming ln P by P naught equal to minus AV. So dp by dv equal to minus AP. From there dp by P is equal to minus AdV. From there you are getting the equation ln P is equal to minus AV plus C. Just put the boundary condition. P at P naught V is equal to 0. So just put v is equal to 0, you get the value of constant c. This is called the boundary condition. You can directly get the value from integration also. Then you need to apply just p naught to p. Then you will get this equation ln p is equal to minus ab plus ln p naught. From there onward, p is equal to p naught e to the minus ab. Just replace p by rt by v. So rt by v is equal to p naught e to the minus ab. From there, t is equal to v by r p to the p naught e to the minus ab. Then do one thing. Just differentiate it with respect to v. P naught by r e to the power this for this term v to the power minus ab, just differentiate by uv function. So you are getting the value of v as 1 by a. So as this is a single value, so this could be the point of maxima. So just put the value of v, t is equal to p naught by r. V is 1 by a e to the power minus a into 1 by a. So it comes p naught a by r. Option D is your answer. Now moving on to the next question. An air bubble of volume 1 cm rises from the bottom of a lake 40 meter deep to the surface at a temperature of 12 degrees centigrade. So this surface is at 12 degrees centigrade. Initially here the volume is V and the deep is 40 meter. Atmospheric pressure is 1 into the 5 Pascal. Density of water is 1000 kg per meter cube. G is acting 10. There is no difference of the temperature of the water at a depth of 40 meter on the surface. The volume of the air bubble when it reaches the surface. In this type of question, you just need to apply the isothermal condition. Here P1 V1 should be equal to P2 V2 because the temperature remains same. So at depth, just you know the value of P and volume volume of 1 centimeter at here. So just need to know the value of P. P is equal to atmospheric plus rho into G into H. So P is 5 into 5, V1 is 4 by 3 pi into 1 cube. I am keeping it in centimeter. P2 is 10 to the power 5 and V2 is 4 by 3 pi into, let the radius is R. So all these get cancelled out and you can find out the value of R. From there you can find out the value of the volume. So you are getting the 5 as the answer. Now one last question. In the next question, a long metallic bar is carrying heat from one end to other end. On a steady state, the variation of temperature theta along the length x of the bar from its hot end is best described by which of the following figures? So the graph is theta versus x graph. So let's say this is T1, this is T. The temperature in between is theta. This is theta 1, this is theta 2. And let's assume this is x. So delta T is equal to, delta T means you can write theta 1 minus theta. This one is equal to Q is equal to theta 1 minus theta, that is delta T, by RTH, that is L by K. So you can treat as this one constant or just write x by K. So your equation becomes K by x, theta 1 minus theta. Now what you can do, you can write this Q is constant in series. So you can write Q by K equal to theta 1 minus theta by x. Write down Q by K as M, theta 1 as C. We are getting theta is equal to C minus mx. That is y is equal to minus mx plus c. That means it will be a straight line having positive slope and sorry, having negative slope and positive intercept. So option B is your correct answer. Next, this one we did, this one. In a process, temperature and volume of one mole of an ideal monoid gas varied according to the relation Vt equal to K. K is a constant in this process. The temperature of the gas increases by delta T. The amount of heat absorbed by the gas is. So, just write it in the term of PV. So, T is equal to PV by, so you can write PV square by 2 is equal to constant. Now, apply the formula of C. C equal to CV plus R by 1 minus 6. For monatomic CV is 5 by 3R. R is R 1 minus X.
5 by 2R.
5 by 2R, sorry. 3 by 2R. 3 by 2R. CP is 5 by 2R. So 3 by 2R, R 1 minus X is 2. So 3 by 2R minus R by 2 minus R. That becomes R by 2. This is C. So Q is equal to C into delta T. So R by 2 into delta T. Wherever this type of question will given to you, like any arbitrary process, make it to PV and then apply C. There is a simple pendulum made of a bob of mass m and a metallic wire of negligible mass has time period 2 seconds at t is equal to 0 seconds. If the temperature of the wire is increased and the corresponding change in time period is plotted against temperature, the resultant graph has a slope s. If the coefficient of linear expansion of metal is alpha, then the value of s is. So there is a graph you need to draw, that is temperature versus time graph. So you know that for a simple pendulum, T is equal to 2 by root over L by G. So this is time versus temperature graph. Temperature I am writing by theta. So dt by t, and time I am writing by t. So dt by t should be equal to del L by L. Del L by L is alpha into delta theta. You know from the stress strain graph. So dt by d theta becomes 1 by 2 alpha t. This 1 by 2 alpha t is the slope of the graph. This is the slope of the graph. It is given that the time period is 2. So alpha by 2 into 2. So S become alpha. The value of S is alpha. Okay. Now next question. At what temperature a gold ring of diameter given is to be heated so that it can be fitted on a wooden bangle of diameter something. So there is a gold ring and there is a wooden bangle. So the wooden bangle is of larger size, the ring is of shorter size. So this will only get fitted if it get a volume, if we get a strain. If it get a strain. So let's assume this is D and D final, and this is, or this perimeter you may write 2 pi r, r is r final, this is 2 pi r initial. So you need to make this 2 pi r initial to 2 pi r final, and this is 2 pi smaller, you can write this is 2 pi capital R. Now just write down the equation of the strain. 2 pi r 1 plus alpha delta t should be equal to 2 pi r. So this 2 pi r 2 to get cancelled out, this pi r is your d, initial d is 6.23, 1 plus alpha delta t 6.241. In this problem, the main issue will be the calculation. So 1 plus alpha delta t should be equal to 6.241 by 6.230. You can write it by 1 plus 0.11 by 6.230. And henceforth, if you solve this one, you will get option D as their answer. Now next question, 260. In my elasticity video, we have solved this one. There is a wooden wheel of radius r. There is a wooden wheel of radius r, and there is having cross section area. If I draw this one, this is actually the image. Let's reverse it. Okay, so you need to clamp this one, these two wheel. There is radius r, and L is like a wooden radius r is made of two semicircular parts. The two parts are held together by a ring. You need to tie up it with a ring by ring made of a metal strip of cross sectional area S and length L. L is this cross sectional area is S. L is slightly less than 2 pi r. To feed the ring on the wheel, you need to increase the temperature by delta T. So the ring is having length L, and L is less than 2 pi r. So you need to increase the temperature of the ring. Delta L is equal to L alpha delta T. Now L plus delta L should be equal to 2 pi r, and delta L is equal to FL by AY. So for the force, there are two surfaces, so S will be 2S. In this cross section there is 1S, there is one more S, so that will be 2S. So this is 2S Y. So F is AY, delta L by L. Delta L by L is the strain. Strain is alpha delta T. Y will remain as it is. In place of A, you can write 2S into Y into alpha delta T. So this will be your answer.